centered at the origin and trace clockwise. So if this was me starting this, what do you think I would do first? Absolutely. So if I draw a picture of this, there's actually a straight line drawing tool I should get better at. Centered at the origin, it's got a radius of 3. So kind of like this. And it goes which direction?
Clockwise.
So it's going clockwise. Does it tell us it has to start at a specific point? No. So it could start anywhere. So could you theoretically each come up with a slightly different answer to this? Sure, theoretically. Now, what do we know this looks like? What does x of t equal cosine t and y of t equal sine t? What does that look like? That's a circle, radius what? Radius 1, starting where? Starting at 0 is not a point. Starting at
0, 0.
No. What's cosine of 0?
1.
1.
1, 0.
So it starts there. So that one starts at 1, 0, and it rotates which direction? Yeah. Counterclockwise. No, anticlockwise. I got it. It's totally accurate. I think it's counterclockwise. Remember, this was the first one we did. Does it go counterclockwise? Well, you can test it. Let's try another value, pi over 2. What's cosine of pi over 2? Root 2 over 2. And what's cosine of pi over 2? So, no, excuse me. Pi over 4, I meant. What's cosine of pi over 4? Root 2 over 2. And what's sine of pi over 4? The same thing. So if we were tracing these out, we would have started at 1, 0, and then it goes this way. It goes this way. So this definitely goes counterclockwise. Okay, so let's take care of each of these things. So this is not quite what we want. We want it to have a radius of what? 3. Anybody have a suggestion about how we can make the radius larger? How do we get this to start further out? Yeah, times both sides of the equal. Well, A, we don't. Not quite. We're actually not going to multiply both sides of the equation. How would we modify this right there to make this a circle of radius 3? Nope. That would change where it starts. It wouldn't change the radius. Well, why does this have a radius of 1? Do you remember the work we did to make sure that this was a unit circle? What did we do to both sides? We squared them and added them together, and we got x squared plus y squared equals cosine squared plus sine squared, which is 1, correct? But we want it to equal 3. So yeah, exactly. If we change this to x of t is equal to root 3 cosine t, and y of t is equal to root 3 of sine t, that's why I said we only on one side on this, so I wasn't super specific. So it's one side on this. When you square and add these together, if you were to square and then add, what do you end up with? X squared plus y squared is equal to 3, yep, plus squared t, and that's 3 times cosine squared t plus sine squared t, which is equal to 3. So x squared plus y squared equals 3. Oh, that's a circle of radius what?
3.
No. That's circle of radius root 3. So we're doing this by experiment. We're close. So what do we change it to?
3.
So that means radius root 3. So instead of making it root 3, so we now know that what do we want? We want it to be x of t is equal to 3 cosine t, and y of t is equal to 3 sine t. Now, that's the right radius, but does it go the right direction? We want it to be clockwise. What does it rotate? Counterclockwise. We want it to go the other direction. How do we get it to go the other direction? Switch the
sign.
So maybe switch this. So this is good, but counterclockwise, right? So, Ali, what was your idea? What was your first idea?
Turn 3 cosine t into 3 sine t for x.
Yeah, so maybe do it as x of t is equal to 3 sine t, and y of t is equal to what?
3 cosine t.
Does that change anything about the simplification, the unparameterization? No, it doesn't. But does it change the direction? Does it change the direction? Well, let's check. What's at 0? Let's do times. Let's make a table here. 0 x, and y. At time equals 0, what's sine of 0? 0. What is cosine of 0? 1. Oh, so 3. Yeah, okay, so 3. Yep, thank you. And then how about pi over 4? What's sine of pi over 4? So it's going to be 3 root 2 over 2 and 3 root 2 over 2. So this one started at 0, 3, and then it went to here. So which direction is it going? It's going clockwise. Do you see why it's going clockwise? Time equals 0, it was here. At what's this point right here? 0, 3, right? And then at time goes forward. So where does it go to? What's that next point right there? 3 root 2 over 2, comma, 3 root 2 over 2. And what direction is that? That is clockwise. So Ali, great idea. There's lots of other ways to do it too. There really are lots of different ways to do this. If you just switch them, that also does the same thing. Does that kind of plus 1? How can we prove that this is correct? Before you square it, what do you have to do? You have to do so here. Yeah, we could make a table and agree with the table, absolutely. But if we wanted to prove that this is in Cartesian coordinates, non-parametric, what do we have to do first before we square both sides? Nope. If I square both sides right now, what's going to happen? Subtract 1. So you now know that x plus 2 squared plus y minus 1 squared is equal to 25 times cosine squared t plus sine squared t. But what is that? 25. And literally, what is this? Is that what we want it to be? Yeah, because this is a circle of radius 5 centered at the point. Oh, hold on a sec. At the point what? What's the center of this circle right here? Negative 2, 1, right? What do we want it to be at? 2, 1. Ah, so what should we change this to? This needs to be a plus. Yes, x minus 2 is equal to cosine t, and what? Y minus 2 is equal to negative sine t. If I'm to add in square, what do I end up with? You end up with this. Yes, equals cosine squared t plus sine squared t. But what is cosine squared plus sine squared? 1. We have a circle. Center where? 2, 2. Radius of what? Radius of what? 1. And then I guess what's the last thing you could say? What's the last thing you would need to describe the motion? Yeah, rotates what? You have to be careful with it. Literally, you could just plug in some values again. So that's what they mean. Okay, so you said you wanted to see 49 as well? Does this make sense, what we just did right there? Kind of based on, okay. Okay, two particles move in the xy plane. At time t, the position of particle A is given by those two, and particle B is given by those two. If k equals 5, do the particles, if k equals 5, do the particles ever collide? So the first thing is, if k equals 5, what do the equations look like? If k equals 5, you have x of t is equal to 4t minus 4, and y of t is equal to 2t minus 5. And for particle B, is there any k's in that one? No, I don't think so. So it's just x of t is 3t, and y of t is equal to t squared minus 2t minus 1. So for two particles to collide, what has to be true? They have to be at the same place at the same time. Cars drive on that road all the time, but they rarely crash into each other because they're not in the same place at the same time. They can drive on the same road a lot of different ways. So how do you figure out if these two particles can't collide? Anybody have an idea?
Just let the x part.
Yeah, let the x part equal to each other and say, okay, for them to collide, the x part at least has to be the same, right? So what does that mean? It means that t is equal to 4. So the only time they have the same x value, the only time they have the same x value is when time equals 4. So what do you do if that time equals 4?
Plug into y.
You plug it into the y values, and what do you get? Y of 4 over here is equal to 8 minus 5, which is 3. And over here, you get y of 4 is equal to 16 minus 8 minus 1, which is 7. These are
9.
not equal. So the only time the x values are the same is when t equals 4. But what happens at time equals 4? Do they have the same y position? No. So what does that tell you? Do the particles collide?
No.
No. And if you wanted to say this, because you could do it the other way too. You could do the y value instead, because you could say because the only time they have the same x value, at that time, they do not have the same y position. Does that make sense? Okay, so just to recap on this, you start with x, lock it in, and find out that the y position is not going to be the same. And then on this one, you lock in what you have to, and then you get to change k to make it true. Check.